Welcome to deepest Sussex. That's a house that's due for completion in 2 or 3 weeks' time, and we've brought you here to show you some of the Greentec systems we have. This house has everything we have to offer, so it's an excellent example of what we can do. The house has solar heating backed up by heat pump. We're heating swimming pool water, swimming pool air. We have a heat recovery system with humidity control, comfort cooling, and some rooms are air conditioned. The air conditioning is passive air conditioning, so it uses about a penny an hour to run. So it's quite an interesting property from our perspective, and let's take you around and show you what we have to offer. Here we are in the plant room. Here's the basic heat pump, exactly the same as the fridge we use in your house. The fridge in your house has the inside is cold and the back of your fridge is warm. The heat pump is exactly the same as this, except in reverse. So the back of your fridge, in our case, is the heating system in the house, and the cold fridge inside in this house is the pipes in the ground. In here we have 2.5 kilometres of pipe in the ground, purely because of the size of the house. Underfloor heating is by far the best means of heating the house when connected to a heat pump. The reason behind this is underfloor heating requires very low temperatures to keep the house warm in the winter. With the lower the temperatures, the more efficient the heat pump becomes. We also use the concrete screed that covers the underfloor heating pipes. So in effect, we're heating the house by heating the concrete screed or the thermal mass within the building. The heat pump heats the house 24 hours a day, keeping the house at a constant temperature, a temperature that you choose to live in. Okay, we're up in the loft of the property now. An awful lot going on up here. What we have far behind me is the heat recovery ventilation system. This is extracting all of the air out of the wet, smelly areas, bathrooms, kitchens, utility rooms, and is bringing fresh, clean, filtered air to all the living areas, bedrooms, living spaces, etc. The warm air that's being extracted through a simple heat exchanger heats the fresh air coming in. Nice, simple method. Okay, we're in with the hot water tanks now. There's two 450 litre tanks of usable hot water. Each is surrounded by 300 litres of water in which we heat it. So in total it's 1500 litres of hot water stored. Primary source of heating, of course, is the solar. Solar's coming down through the pipes at the top here. At the moment, as you can see, there's 50 degrees coming in on this spring day into the solar. So the solar panels are easily heating hot water. When the hot water's been satisfied and it's up to temperature, the heating then gets transferred to the energy cells, and all the heat is stored in the energy cells. Okay, we're in the back of the garage now, and on the back wall of the garage we have our energy cells, 16 of them. These energy cells do one thing: they store heat. It's either generated from solar panels or from the heat pump at night using cheap rate electricity. The heat pump will only come on at night using cheap rate electricity if there's no heat being generated by solar during the day. So these, for a better effect, are our energy storage cells. All they do is store heat. Once the heat's in them, they heat everything in the house. Underfloor heating, hot water, swimming pool water, and swimming pool air. So as much as we can, we're taking the energy created from the solar panels, storing it in our energy storage cells, and heating everything in the house. Only when there's not enough energy in these storage cells does the heat pump come on and take over from the storage cells. It's a spring morning, nice sunny day. The solar's heating the hot water first and heating the energy cells second. But what you can see from here is the temperature that's being stored at the moment in the energy cells. So at the moment we have 30 degrees of heat being stored in these energy cells. That's being created from the solar panels on the roof. Okay, we're on the roof of the property now. where our bank of solar panels are. Evacuated tubes, the most efficient, perhaps not the prettiest, but in a house like this where we put them on the roof and they cannot be seen from the ground, the best possible solution. Again, the heat that's generated by these goes firstly down to the hot water tanks and heats the hot water, then it goes off to heat the energy cells and store the heat for any heating demands that may be needed later on in the day. Okay, we're up in the loft of the property now. In the middle here, and behind me, we have the humidity control. And humidity is very important, and I think it's mostly overlooked. But we keep the house at a constant 50% humidity, the perfect living environment. With the correct humidity, you don't need to heat the property so much, so it actually does save in energy as well. So as well as being healthy for you, this is an energy saving device. Lastly, over to the left there is the cooling coil. It's our comfort cooling coil. The cooling coil is attached to the inlet ducts that supply all the living areas. And we get the coolant from the ground pipes in the ground that are connected to the heat pump. So we have an abundance of free coolant available to us by simply switching the circulation pump on, which is there, running fluid that's in the ground up through our cooling coil. We can cool the whole house down for the cost of running a circulation pump, about 5 pence a day. "11 degrees. This is the gym in the house, and we're cooling it via our passive air conditioning system. The air conditioning system is very simple. We're extracting from one vent, running it through a cooling coil, through a fan, through a filter, and then bringing the air back into the same room. The coolant that provides cooling for the air conditioning is coming from the ground. From the coolant in the ground has been created by the heat pump. So in effect, we have free coolant. This is the air conditioning system. Approximately running costs for this air conditioning system about £0.01 an hour. It's full air conditioning, it's fully automated, it comes on and off at certain temperatures. Very end of the plant room now. What we have here is the pool pump and filter, and from our point of view, the pool heat exchanger. This heats the hot water in the swimming pool. Again, two sources of heat as far as we're concerned. Firstly, solar, so there's enough energy in the solar cells, the solar will heat the swimming pool water. If there's not enough heat in the solar cells, the heat pump comes on and heats the pool water instead of the solar. Greentec have our own proprietary control system. This system controls all the heating in the house and all the cooling. It controls the comfort cooling, which is a whole house system, and the air conditioning, which is a room by room cooling system. The cooling works automatically, so when the room wants to get up to temperature, shall we say 21 degrees, it will control the heat up to 21 degrees, then switch off. If the heat continues to rise in the room up to 23 degrees, the cooling automatically comes on to cool the room down through our passive air conditioning system. So what you have now is a control system that can control different temperatures throughout different parts of the house. Conclusion, we can be cooling the room for nothing using the ground pipes, and we can be heating the other room for nothing using the heat stored in our energy storage cells.